Okay, so I'm going to finish up 5.2. We probably will finish early today, maybe considerably early. If I have a chance, maybe I'll sneak in a little bit of 5.3. Tomorrow's a holiday for Veterans Day, so no classes, not just my class, any CSM class. So enjoy your one-day weekend, as I call it. We'll meet again on Thursday. And then Thursday, I'll tell you what the quiz would be on Friday. Okay. So I'll finish up 5.2, maybe sneak in a little bit of 5.3. I think we have plenty of time to finish all this, but we'll see how it goes. Okay, so 5.2 isn't that long, but 5.3 is definitely longer. And 5.4, you can see I have all ALL, which means the evens. I'll try to do a lot of evens. But 5.4 is on exponential growth and decay. They're basically all word problems involving the exponential function. So I'll try to guide you through those. Okay. So let's try to get what we need to for 5.2 today and see how it goes. And if time permits, I'll sneak in some of 5.3, and I think we'll probably still finish early. Okay. All right, so back to 5.2. So we have our basic exponential function, and we've played this game before. We're going to do stuff to it. Okay, move it left, right, up, down, double it, cut it in half, reflection across the x-axis, take its absolute value, and weird stuff like that. Then after that, we have a few inequalities to deal with. Okay, so we'll see how to do those. All right. Okay, so number 7, f of x equals negative e to the x minus 1. Okay, now just a side note for this chart, okay, you should know quickly that e to the x looks like this, but in case you want to know what some of the values are, you could plug these in. Okay, so that means on your calculator, which I'll go ahead and get now, and you don't really need to do this with me now if you don't want to, but if you want to, just to get a few of your e to the x button. Okay, so if I plot e to the x, I got a little table here for x values from -3 to 3. Now we already know that e to the 0 is 1. I showed you the other day e to the 1 is 2.7. Okay, but if you just want to confirm that with me, second function e to the first power, see e to the 1, 2.71828, whatever. I know it's hard to see, but hopefully you can try it on your own. Oh, that's a little bit better, I think. Okay, plug in 2, you have e squared. So e to the x, again, it's above the ln. So you look above the ln, e to the x. So second function, e to the x. And then I want 2. Whoops. There we go, e squared. 7.38, so I call it 7.4. And then e cubed. So again, to get e to the x, it's above the ln button on most calculators. Second function, e to the x, and then 3. And you can see e cubed. And about 20.08. I just call it 20. Okay, and then quickly through the negatives. -1, e to the -1. So second function, e. And most calculators, if you have something like mine, this one is the negative, not this one. This one is subtraction, and you can tell because it's lined up with divide, times, minus, plus. So this minus sign is the regular subtraction. This is the one that get a negative down here. So e to the -1. So there's e to the -1. 0.367, rounded up to 0.37. And then e to the -2 and e to the -3. So second function, e -2, whoops, sorry. 0.135, rounded off to 0.14. And then same thing, second function, so e to the x, second function, e, and then again, negative is this one down here, -3rd. So e to the -3rd. 0.0497, call it 0.05. Okay, so anyway, that's in case you want to see how to get the numbers, e to the x on your own calculator. Goes like that. Okay, so here's the progression. E to the x minus 1, that moves the whole graph 1 unit to the right. Okay, so I take the red, the original graph, move everything 1 to the right, and then it looks like that. And then finally, what I want in green, a negative in front of the whole thing, means you just reflect across the x-axis. So e to the x minus 1, negative e to the x minus 1. So it should look like that. Okay, so that's all. That's a basic idea for the problems that we're going to do today. Right, and you're welcome to put sample problems like this on your cheat sheet if it'll help you on the test. That's perfectly fine. Okay, number 5. I actually didn't do it, but I'll just talk quickly about the graph of 1/4 to the x. Okay, we know it falls like that. But I plugged in 0, 1, and -1. Okay, so if you plug in 0, 1/4 to the 0, well, we already know that anything near the 0 is 1. Plug in 1, 1/4 to the 1 is 1/4, so that's down here somewhere. -1. 1/4 to the -1 means you flip the fraction. So 1/4 becomes 4/1 raised to the +1. That gives me 4. So -1/4. Okay, so it drops something like this. You have a horizontal asymptote at y equals 0. Okay, so for this one, I just gave you hints here at what happens. The 3 means you multiply by 3. So can you guess instead of 0, 1, it would be 0, 3. Okay. And then shove over 1 to the right and 2 up. Okay, so I'll let you work on that progression after that. So 0, 1 becomes 0, 3. Okay. If you just think of 3 times 1/4 to the x, it'd be 3 times 1, which is 3. That's up here. Okay. Then move 1 to the right and then 2 up. Okay. So we've seen that theme before. You should be comfortable with that kind of stuff if I give it to you on the test. Okay. 9's a little bit tricky. There's a lot of stuff going on. I actually have, let's see, 1, 2, 3, 4, 5 different graphs all going on at the same time. So I'm sort of giving you the progression of what happens for this one. F of x equals 2 minus e to the negative parentheses x minus 3. Okay, so there's a lot of stuff going on there. And I'm going to rewrite it like this. Negative e to the negative parentheses x minus 3 plus 2. So this is the same as this. All right, so there's actually 5 graphs that are going on in this particular problem. So a lot of stuff going on here. So I start with my basic function e to the x. Okay, and by the way, you should be able to show me the progression of graphs on a quiz or test, right? So rather than just showing me the answer, say, okay, I start with e to the x, and then I did this, step 2, and then I did this, step 3, and then I did this, step 4, and then I did this, step 5, until you finally get that. Okay, so I can see your logic, follow your logic, and that is considered showing work, and that way I can give you partial credit if something's wrong also. If you go straight to just drawing a graph and it's wrong and I don't see any other work, I'm very likely not to give you as many points as if I see this progression. Okay, so the base function is e to the x, right? All exponential functions in general look like that. They go through 0, 1. Right? So remember this picture I showed you yesterday, right? So a to the x, if a is bigger than 1, they all look like this, just a measure of how steep it is. And they all touch at the same point, 0, 1. Right? And then if the base is between 0 and 1, they all fall, and they still all go through 0, 1. Okay? All right, so e to the x, there's a negative, so then I do e to the negative x. So that falls instead. Still going through 0, 1. So that's graph number 2. By the way, e to the negative x, you can think of as 1 over e to the x. Okay? And 1 over e, that's 1 over 2.7. Okay? And just for fun, oh, we already did that. That's like 0.37 from the chart here. Yeah, so pretend this is like 0.37 to the x power. That's between 0 and 1, so it's going to fall. Okay, now what did I do from 2 to 3? E to negative x, e to the negative parentheses x minus 3, right? So that's going to take the graph 3 units to the right. So if you take this red and this red, okay, imagine taking this red graph moving at 3 to the right. So all I did was I moved 0, 1 to 3, 1, if you can kind of see that there. Okay, so this matches, the red matches the red, except that this got shoved over to the right by 3 units. So I just took 0, 1 and moved to 3, 1. Okay, so that's my third graph, graph number 3. E to the negative parentheses x minus 3. So I'm just building up one by one, step by step, until I finally get what I want. Okay, now graph number 4. So look at 3 and 4. The difference is there's a minus in front. Okay, so for this graph, e to the negative parentheses x minus 3, it's all above the x-axis. They're all positive. So putting a minus would just make all the positives negatives, so it'll reflect across the x-axis. So graph number 4 now, this green graph here is a reflection of that red one across the x-axis. So now negative e to the negative x minus 3. So 3, 1 becomes 3, negative 1. So it's down here now. By the way, a little double check on this. What happens when you plug in 3? Right, well, 3 minus 3 is 0. Negative 0 is still 0. So e to the 0 is 1. And then the minus in front of the whole thing makes it negative 1. And then finally, graph number 5 here, plus 2. So from here to here, plus 2, move this graph 2 units up. So 3, negative 1 goes back up to 3, 1, which I already labeled in red here. Okay, but I just draw the same graph as this. So my final answer is this green graph here. I ran out of colors after a while, as you can see. Okay, so there's a lot of things going on here. There's 5 different graphs for this one problem. Okay, so let me go through that again one more time. So we have a lot of stuff here. So the original was 2 minus e to the negative parentheses x minus 3. So I started off with e to the x. Then I see the negative there, okay, e to the negative x. Then I see the parentheses x minus 3. So parentheses x minus 3, 3 to the right. It's sort of like I'm trying to make my function grow, quote unquote, until it ends up looking like that. Okay, so that means right now I have that stuff, right? I have e to the negative x minus 3. So there it is, e negative x minus 3. And now I still need that minus sign and that too. So how do I get the minus sign in front? That is graph number 4 now. That's a reflection across the x-axis. So now it's negative e to the negative parentheses x minus 3. Negative e to the negative parentheses x minus 3. So I have everything besides the plus 2. And we know what to do with the plus 2. That means move the graph 2 units up. And then I got it. Okay, so graph number 5 is my final answer. Negative e to the negative parentheses x minus 3 plus 2. The plus 2 is here, but that's the same thing as the original where they put the 2 in front. All right, so graph 1, 2, 3, 4, and 5. So that's that. Okay, then 13, f of x equals negative e to the absolute value of x. Okay, so let me start with e to the absolute value of x. This has y-axis symmetry because it becomes an even function. When I put the absolute value there, I get the same thing if I plug in 1 and negative 1, 2 and negative 2, 3 and negative 3, and so on. Okay, it has y-axis symmetry. It's an even function. FCN is my abbreviation for function. FCN is function. F of negative x equals f of x. Okay, so here's the logic. On this side, regular e to the x. I know it says e to the absolute value of x, but I get that. Okay, so this is just regular e to the x. Well, just like this one right here, right? E to the x. Let's see, where'd it go? Lost my place. E to the x. So if I plug in 0, 1, 2, 3, 4, then this part of the graph is exactly the same as this part over here, right? So if I kind of just don't even look at that, that part should match. Because absolute value of x and x are the same thing when x is greater than or equal to 0. So that part's the same. Now, because I have y-axis symmetry, I don't do the rest of this, right? If I have y-axis symmetry, I just take the mirror image, the reflection, across the y-axis. So if I pretend I put a mirror right there, that's what I got, e to the absolute value of x. So because of the absolute value, I'm no longer doing this. I am doing this for this part. This part stays the same, right? Because if I plug in 0, 1, 2, 3, 4, 5, 6, it doesn't matter if you have x or absolute value of x, it's the same thing, right? Where it's going to differ is when I start plugging in negative numbers, right? So I start plugging in negative numbers, then we know e to the negative 1, e to the negative 2, whoops. Oh yeah, and so on. We're going like this. But because that's absolute value, I'm not really taking, if I plug in negative 1, I'm not doing e to the negative 1. I'm doing e to the absolute value of negative 1, which is e to the 1. And if I plug in negative 2, I'm not doing e to the negative 2. I'm doing e to the absolute value of negative 2, which is 2. So it ends up going like this. So this is the graph of e to the absolute value of x. Okay. And the way I drew it, it almost looks like a parabola, but it's not really a parabola. Officially, it's not a parabola. All right, and then finally, negative of that, reflection across the x-axis. So the red is my final answer. Okay, so that's that. All right, then we have some inequalities. (15, 17). So we'll just do a rough sketch and then go off of that. Okay. E to the x is greater than 1. Just look at the graph. Here's e to the x. Here's the point 0, 1. So when is e to the x greater than 1? Well, that's everything above here. Right? So what x values would make that work? X is greater than 0. Or in interval notation, from 0 to infinity. And if you stop and think about it, if I plug in 0, I get 1. If I plug in 0.00001, you get something a little bit bigger than 1. Okay, according to the graph. We can verify that. Sorry for burning out your eyeballs. Okay, I'll try e to a number very small but a little bit positive. So if e to the 0 is 1, e to the 0.001 should be 1 point a little bit, right? There it is, 1.0001005 or whatever, okay? So there we go. Okay, then 17. One-fourth of the x is greater than or equal to 2. This time it says greater than or equal to, so we're probably going to be including an endpoint. Right? So first I graphed 1/4 of the x is, one-fourth of x is greater than or equal to 2. Let me just go ahead and make a table here. So I just plugged in, -2, -1, 0, 1, and 2. Okay. So I plug in 0. Anything that is 0 is 1. Plug in 1, I get 1/4. Plug in 2, I get 1/16. -1. Now, 1/4 to the -1, we talked about this already. You flip the fraction, +4 to the 1 power. That's 4. Plug in -2. 1/4 to the -2, flip it, 4 to the +2, 16. By the way, you may also notice a pattern. If I go this way, it looks like I keep multiplying by 1/4. Right? 1/4 of 16 is 4. 1/4 of 4 is 1. 1/4 of 1 is 1/4. 1/4 of 1/4 is 1/16, and so on. Which means if I were to go backwards, I keep multiplying by 4. 4 times that is that. 4 times that is that. 4 times 1 is 4. 4 times 4 is 6, and so on. Okay, so crudely it goes here. Okay. So where is here? I want y to equal 2. Okay, so 1/4 of the x greater than or equal to 2 is going to be greater than or equal to whatever this value is. Okay, so how do I find out where that value is? I can solve the equation 1/4 to the x power equals 2. Okay, and I recall how to solve something like this. How do you solve that without a calculator? You try to write both of these sides as base 2. Okay, now 1/4 I can treat as 4 to the -1, right? So 4 to the -1. And then I'm allowed to multiply these, right? -1 times x is 4 to the -x is equal to 2, which I'm going to choose to write as 2 to the first power. Okay, now can I write that in terms of base 2? Yes, 4 is equal to 2 squared. So if I kind of cover this up, here's 4, right? 4 to the -x. So 4 to the -x, right? 2 squared, 4 to -x. Now what do I get to do over here? Multiply the powers, right? If you have a power and then another power, you multiply the powers. 2 to the -2x equals 2 to the 1. Okay, and this is the key. Once I get it to be like this, bases are the same, base 2, then I can equate the exponents. Okay, so again, 2 to something equals 2 to something. Maybe just cover this up. 2 to whatever, 2 to whatever. These two things floating up here better be the same, right? In order to be equal. I mean, like pretend if this side is 7, this side better be 7. It can't be 8. It can't be 6, right? So whatever exponent is here has to equal whatever exponent is here because they both have a base of 2. So I just set these equal, and that's easy. -2x is equal to 1. X equals -1/2. Okay, so going back to here, I now know that this is -1/2. So what solves this inequality? 1/4 of the x greater than or equal to 2, i.e. the y coordinate is greater than or equal to 2. So that's if x is less than or equal to -1/2, right? Everything over here, if I have x -1, -2, -1,000,000, it's way over here. It's going to be greater than or equal to 2. Okay, so I want to say x is less than or equal to -1/2, or in interval notation, parenthesis, -∞, comma, -1/2, and bracket. Bracket because I'm including the -1/2, the endpoint right over here. Okay. Okay, and that's about it, folks, except for 19, then I'll be done. Okay, so 19, and then maybe I'll sneak in a little bit of the next section. But otherwise, if you have no other questions, I'll be pretty much finished. So if you want to think of something you want to ask me in a few minutes, I'll be done. And you can ask me stuff or put it in the chat or unmute yourselves. Otherwise, we're about done. So question 19 was the last problem here. Yeah, reminder, we're skipping 35 and 37. So 1 to 19 is matching A, B, C, D, A, B, C, D. Okay, so look at these various graphs, right? Okay, well, Roman numeral 1 and 4 are the most quote-unquote normal. Okay, 2 and 3 seem to have something extra to it, like adding and subtracting stuff. Okay, this one, it's falling, a regular exponential, except the base is less than 1. This one is a regular exponential, except the base is bigger than 1. Okay, so let's take a look. I notice this goes through 0, 2, not 0, 1. So there's probably a 2 involved somewhere. Aha, that's C. Right? So for 19, C must be Roman numeral 4. It goes through 0, 2. And by the way you can check it, of course, is plug in 0. If you plug in 0 right there, e to the 0 is 1, 1 times 2 is 2. So it has to touch 0, 2. None of the other ones touch 0, 2, so that's it. All right, so again, C is Roman numeral 4. Okay, the other easy one was this one. It's falling. It goes through 0, 1. So the base must be less than 1. And you're not adding or subtracting anything, so it should be D. Okay, so D is not Roman numeral. Oh, yeah, it is Roman numeral, I guess. Okay, number 1. Okay, e to the 0 is 1, goes through the origin, and it's falling. Remember, e to the negative x is like 1 over e to the x power. Okay, so it falls like so. Okay, so that leads to more complicated ones, 2 and 3. And how should we attack 2 and 3? Maybe the easiest way to do it is to notice that number 3 goes through the origin. Right? So I can just get it by picking which one touches the origin. So how about A? Does that touch the origin? Plug in 0? No, no way. Does B touch the origin? Yes, it does. I plug in 0. E to the 0 is 1. The negative makes it negative 1. Negative 1 plus 1 is 0. Right. So B must be 3. So by process of elimination, that forces Roman numeral 2 to be A, I guess. Yeah. And it does make sense as a minus 2, so it drops the graph down. So that pretty much does it. Okay, so I'm finished with 5.2. Okay, it's only 9:40. You can go ahead and ask questions, but I would just do a quick introduction just to make it easier for me on Thursday. I was about to say tomorrow, but we're not meeting tomorrow. But this would just help me when I get to that. So I'm not doing any problems in 5.3. I'm officially checking off 5.2, meaning I'm finished with it. Okay, and I'll start 5.3 on logarithmic functions. Okay, on your calculator, you have the buttons log, which means base 10. If you ever forget, just peek up here, 10 to the x. And ln, which stands for natural log or log natural, the base is e to the x, as you can see over there. All right, so these are exponential functions. Okay. Quickly about log functions, and you should have seen logs before in your intermediate algebra. Okay. Log functions, we're going to see stuff like this. Do you remember this? Y equals log base a of x means the same thing as x equals a to the y. So the way I like to think of it is start with the base a. You go across the equal sign for the exponent, y. Then you come back in for the result, x. So this means a to the y is equal to x, or x equals a to the y. Okay. X is defined from 0 to infinity. So when you're taking logarithms, you can only plug in positive quantities. You can't take the log of 0. You can't take the log of a negative number. Okay. And let me see if I can just show you that. I'm going to try log of 0. Sorry. Log of 0. I should get some kind of error message. That is error domain or whatever, right? Log of 0. Okay. And likewise, you cannot take the natural log of, say, a negative number. So let me try natural log of negative 1. Okay, the calculator actually gave me something. That's a complex number. Okay, it actually looks like 0 comma pi. That's actually a plus bi. It's 0 plus 3.14. That's pi I. Okay, well, we're not doing any of that stuff right now. So as far as we're concerned, ln of a negative is not real. It's not a real number. Okay, so I'll be showing you how to do stuff like this. like this, and so on. Okay, and some properties of logs. Okay, the log and the exponential function are inverse functions. Okay, this is the exponential function. The log function is the inverse. And that was the reason why they listed it on your calculator this way, that these are inverses, right? Sine, cosine, inverse cosine, tangent, inverse cosine. So log, inverse log, 10 to the x. ln, inverse ln is e to the x. Okay, so that means whenever you do something like this, okay, if you have a log followed by an exponential, they cancel out with y. Or if you have an exponential followed by a log, they cancel out. So if you see something that looks like this, log base a of a to the y, it's always y. Or a raised to log base a of x, that's just x. So the a, log a, exponential log cancels out. Log exponential cancels out. And again, if you want to put that in your next cheat sheet, let me put that in your next cheat sheet also. Okay, here's some properties of logs. Log base a of 1 is 0 always. The reason for that is because if you unscramble it, a to the 0 is equal to 1. And log base a of a is always 1. If you unscramble it, a raised to the 1 power is back equal to a. Okay, we're going to graph some of these log functions. You don't really even have to take notes now. I'll go over all this on Thursday. But log functions tend to look like this. So here's an exponential function, like y equals 2 to the x. Okay, and you might recall you can get the inverse function if you reflect across the line y equals x. So the mirror image across the line y equals x of the blue is the red. This is the log base 2 of x. And you might recall what happened for the inverse function. So they have these points, negative 1.5, 0, 1, 1, 2, 2, 4, 3, 8 for 2 to the x. If you just reverse them, right? Look at 3, 8, 8, 3, 2, 4, 4, 2, 1, 2, 2, 1. They didn't put it, but that's 0, 1, 1, 0, negative 1, 1/2, 1/2, negative 1, and so on. And you just switch all the x's and y's. And so the log functions all generally look something like that. Okay. All right, then another biggie on page 298. Properties of logs. Again, you should have seen these before. The log of a product, log base a of x1 times x2, is log base a of x1 plus log base a of x2. It's the sum of the logs. Log of a quotient, log a of x1 over x2, is log base a of x1 minus log base a of x2. And then the power property, if you have an exponent up there, log base a of x1 to the r power, that r gets to come down in front, r log base a of x1. And by the way, all of these are both directions. So some problems in the homework, you might start off on the right side, bring it back to the left. Same thing, it might start off with a subtraction, bring it to a division, or it might start off with a coefficient in front. You make that coefficient climb back up over here. So it's both directions that we see here. Okay. All right, that's about it, folks. So let me stop the share and check the chat. Okay, so 5.2, number 11. Okay, so 5.2, number 11, e to the 2x. Okay, well, maybe the best way to think about that is to just plot some points. Okay. So problem 11. So let me get going back to share quickly. Sorry, there's no way to do this fast. E to the 2x. Okay, I'm going to make a real small chart. Okay, if I plug in 0, I get 1. If I plug in 1, I have e squared. And if I look back to my table, that was 7.4. If I plug in -1, that's e to the -2. Okay, that was like 0.14. Okay, so if I may just graph that real quickly here. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to exaggerate this direction. Okay, 0, 1. 1 is way up at 7.4. And -1 is quite low. E to the 2x. Okay, now how does that compare with e to the x? So let me pick a different color for e to the x. Still goes through 0, 1, but 1 gives me e, which is about 2.7. So e to the 2x jumps higher. And do we recall what that means about this side? On this side, they switch. So on this side, e to the x is higher. So I'll make it go something like that. So e to the 2x just makes it jump higher on this side, which means it goes lower on this side. Okay. All right. And anybody else with any questions, please? Okay, I'm done with section 2. Have a nice one-day holiday tomorrow. We'll meet again on Thursday and start section 5.3. Okay. All right. So have a good day, everyone. We'll see you on Thursday. Okay. Bye.